Is it e to the negative 6x over negative 6 plus c?
Excellent. Great job. Yes, I have to clean it up a little bit. So it's x to the 4th over 4. Again, this is 3/2. I have to flip it, so it's 8/3 x to 3/2. Minus, now I put the minus in front, e to negative 6x divided by 6 plus a constant c. Let's take a moment and verify if this is clear. 1/2 plus 1 is 3/2, but it's 3/2 in the denominator, so I have to flip it. So 3/2 becomes 2/3. 4 times 2/3 is 8/3 in front. Here I did not do anything other than plus or divided by minus is minus, plus a constant c. Any questions on this problem? So please remember these. Very important. Example. And of course, it works for any number in front of x, like negative 6, for example. Okay. Moving on. Now I would like to look at these problems. Let's see what they are asking us. So let's choose one. If you don't choose, I will. So let's choose from 47 through 56 and analyze and see what is this little thing next to the function, next to the derivative. Any preference?
Can we do 52?
52. Very good. So f prime of x equals 6x squared minus 4x plus 2. And they're telling us that f of 1 is 9. We don't have f. So this is not something that I can use at this point because I don't have the function. I have the derivative of the function, but not the function. Good, so let it sit for a moment. Now, can I find the function? Yes, by anti-differentiating the derivative. So I have 6 x to the 3rd over 3 minus 4 x squared over 2 plus 2x plus a constant c. How come? Because when I differentiate x to the 3rd over 3, I get x squared. When I differentiate x squared over 2, I get x. When I differentiate 2x, I get 2. And when I differentiate c, I get 0. Yes, I will clean it up a little bit. 2x cubed minus 2x squared plus 2x plus c. I'm happy because I have the function. Now let's see what they want with this little thing here. They're telling us, in other words, that when x is 1, the function value is 9. Meaning, when I replace x by 1 everywhere, f of 1 is 9. So then 9 equals 2 minus 2 plus 2 plus c. Why do you think this information was given to us? This is called initial condition. Initial condition. Why do you think the initial condition was given to us?
Is it so you can find out what C is?
Exactly. In other words, they are not interested, the problem is not interested in the most general antiderivative. It's interested specifically in one particular function that such that f of 1 is 9. Only one complies with this condition. So we don't care to find, we had to, but we don't care to find or look at the most general antiderivative. We want that one specific one that passes through this point, 1, 9. So from this equation, can anyone give us C?
be 7.
Very good. So therefore, we are asked to find only one function. Only this function. This is it. And this is a unique situation. It's a function whose derivative must be this, guaranteed. And in addition to that, it passes to the point 1 for x, 9 for y. And there is no other. Any question on this? Okay, so let's look at another problem. Let's choose one more. And let's look at some word problems now after that. Anyone would like to choose, or I will? Okay, I will choose 53. 53 is f prime of x equals 5e to 2x, and they're giving us that f of 0 is 1/2. We do not have f. You cannot even look at this. This has to wait. It means nothing right now because I don't have f. Good. So, can anyone give us the function f of x? Based on what we just discussed a few minutes ago. Which function prime will be 5e to 2x? Anyone will give us a function that we differentiate to get 5e to 2x? Five is 5. Something plus a constant c.
E to 2x over 2.
Exactly. Thank you very much. Good. This is the most general antiderivative. However, this is not what they want. They want us to determine that one, the unique one, just one, not infinitely many, such that when I plug in 0 for x, the function value is 1/2. So 1/2 equals 5/2 e to 2 times 0 plus a constant c. But how much is e to 0?
Is it just 1?
Exactly. E to 0 is 1, so then I have 1/2 equals 5/2 plus a constant c. Can anyone, thank you, can anyone give us c from this equation? One half equals 5/2 plus c, therefore c equals -2. So 1/2 minus 5/2 equals c, so c equals -4 over 2, which is -2. Very good. So then the unique function whose derivative is this and also passes to the point 0, 1/2, that is a unique one on only one function. Which one? This one. Good. Moving on. Okay. Again, what is the use of all this? Here it is. Total profit from marginal profit. Remember, marginal profit is the derivative of the profit. It bears this name. So we are given in 61 on page 393. We are given p prime of x equals 0.02x minus 1.45. So this is something called marginal profit. Okay. So they're giving us the marginal profit. It's in hundreds of dollars per unit because it's a rate of change. It has two measurement units. Hundreds of dollars per unit from selling X. The X parachute is given by. Fine. Find the total profit function, P, assuming P of 0 is 0. This is the initial condition. They want us not to find the most general antiderivative. They want us to find that one whose P of 0 is 0. That's part A. So they want us to find P of X. And then how many parachutes we need to sell for break-even. We know that the break-even point is when the profit is 0. But that's algebra. Okay, so they're giving us the marginal profit. They're asking us to find the most, first of all, the most general antiderivative, and then use the initial condition. We have one possibility is just simply to write P of X and find the antiderivative. The other one is find the indefinite integral from 0.0 to x minus 1.45, always in parentheses and always dx. It's the same thing. Good. So, which function prime is this? 0.02 times x squared over 2 minus 1.45x plus a constant c. How did I come up with this? Well, when I differentiate x squared over 2, I get x. When I differentiate x, I get 1. And when I differentiate the constant, I get 0. There's nothing there. So therefore, I simplify. So then P of x equals 0.01 x squared minus 1.45x plus c. But we are told that P of 0 is 0. So 0, 0, 0, then c must be 0. Because there is nothing else possible. When this is 0, this is 0, this is 0, so c equals 0. So either you use the symbol or you just determine that P of x equals 0.01 x squared minus 1.45x, and this is it. Because c in this case is 0. Now in part B, I have the function, and they're asking us how many units we need to produce for the profit to be 0, because that's the indication for the break-even point. Profit is 0 or revenue equals costs. So all I have to do, this part is algebra, set this equal to 0 and find x. So P of x equals 0 means 0.01 x squared minus 1.45x equals 0. If you don't want to perform any calculations, that's fine too. It's acceptable, it's calculus. Meaning if we're still having trouble simplifying and using the quadratic formula, we move away from this. Because as I said, it's calculus now. So minus 1.45. And don't forget to put 0 as the free term. Okay. So one solution is x equals 0. But when we're manufacturing 0, we have no profit, no revenue, nothing. So this is not possible. And the other one is x equals 145 units. So the break-even point, in case they're asking us, the break-even point is 145, comma, the revenue, I'm just refreshing your memory. We don't have the revenue function. We cannot determine the point. We can only determine how many units we need to manufacture for the break-even point. But the break-even point, in case they're asking us, they have to give us the revenue function so we can plug in 145. So what did just happen here? We were given the derivative of the profit. We were able to, either notation, it doesn't matter, we were able to determine the profit function. We were also given an initial condition to help us determine C because they wanted us to find that unique function such that P of 0 is 0. And then in part B, we were asked to find how many units they need to manufacture to break even. So if they want profit, obviously they have to manufacture way more than 145 and manage to sell them for the profit to exist. Any questions? Any questions? Okay, I know we have about 6-7 minutes, so this completes 4.1. So please redo the problems we did in class from 4.1 and do the homework with minimum of 70% between now and Wednesday for 4.1 and a couple of questions that I will assign. I would like to just start 4.2. You're not supposed to do anything about 4.2, but I just want to explain the setup, at least, of 4.2. Okay. If we're given, or if we are asked, find the integral, the indefinite integral from a function dx. I will have to find the antiderivative plus a constant c. This is not always possible. Mathematically, maybe with a computer, yes, but mathematically with our brains, sometimes this is not possible. So what do I do then? Well, if I am asked to determine something called the definite, this is the indefinite, the definite integral. The definite integral equals a number. Look what happened here. The indefinite integral is a function. This is a function or a family of functions. But the definite integral, which I will show in a moment, is always a number. How will this definite integral look like? For example, the integral from -2 to 4 from x squared plus 2x minus 1 dx. This is something called a definite integral. It has limits of integration. So this is not the LIM that we know for a month and a half. No, this is not what I'm talking about. These are called limits, but not limit that we know about from before. They are called limits of integration. This one and this one. Limits of integration. In other words, x is carved in stone. It's definite between -2 and 4. That's why the answer is always a number. So the indefinite integral will always give us the antiderivative, the most general antiderivative of this function. But the definite integral will always give us a number, and I'll explain where it's coming from. But in certain situations, we will not be able to find the antiderivative for all functions. I can give you an example in which we cannot find the antiderivative. Okay, so then what do we do? For a definite integral, we can approximate this number. We may not be able to find it exactly, but we can approximate it. For the most general antiderivative, we're not going to be able to find it because we cannot find the antiderivative. But here, for the definite integral, we will be able to approximate it. Where does the approximation come from? How is the approximation determined? Okay, so the integral from a to b from f of x dx can be approximated if we cannot find the antiderivative. If I can, then I will not be happy with the approximation, but if I cannot find the antiderivative, I can approximate it. Okay, how do we approximate it? I'm going to start with a very simple example, like x squared plus 1. Do I still have a minute or not? Yes, I have 2 more minutes. I'll stop in a moment. So, how do I graph this function? Well, I know how to graph it. This is x squared up 1. And I'm going to choose the interval 0, 2. So here's the function. When x is 0, I have 1. When x is 1, I have 2. And when x is 2, I have 5. So this is the function. What does this represent is the area under the graph. This area is the integral from 0 to 2 from this function, from x squared plus 1 dx. So the area under the graph, this number, area under x squared plus 1, specifically on the interval 0, 2, is the definite integral from 0 to 2 from x squared plus 1 dx. There is no need for approximation because we can determine the antiderivative, but I'm showing how we approximate it next time, of course not now. I will show on this example how we approximate the area. And this is valid for any definite integral that we cannot find the antiderivative for. Why are we interested? Why on earth would I be interested in the area under a graph? You have to wait till Wednesday.